Okay, so let's see what you have discovered about these horizontal and oblique asymptotes. So hopefully you've done this activity and you've graphed them on Desmos, you've cut them apart, sorted them into the different types, horizontal asymptotes at y equals 0, horizontal asymptotes at a different number, and oblique asymptotes. And so now let's look at what the relationship is between the degrees that you see on these fractions, these rational functions, and what happens to them as far as these horizontal and oblique asymptotes. So you want to compare these. So we're going to take some notes here. So I want you to take these with me. Oops, that's a little large, isn't it? Okay. We compare the degrees of the numerator and denominator. Denominator. Okay, so with that, case 1. Oh, I'm back to big. Case 1. If the denominator has the larger degree, we get horizontal asymptotes at y equals 0. Okay, so let's talk about the reason for that. So degrees are also called powers. Exponents are called powers because they're very powerful. They're the biggest influencer on the size of a number. If you square something, that's going to get really large. Or if you take it to the third power, it's going to get really large. So anyway, if we compare the degrees of the numerator and the denominator, and the denominator is bigger, that means you're going to be putting bigger numbers downstairs in this fraction. Okay? So when you do that, think about like 1 over 10, or 1 over 100, or 1 over 1,000. The larger that denominator gets, the smaller your fraction becomes. Because 1/10 is a small fraction, but 1,000th is way smaller. And then 1 millionth is way smaller than that. So it's getting littler and littler and littler as your x values get bigger. So that makes it approach 0. So that's what gives you a horizontal asymptote at y equals 0. The second case is if they tie. If the degrees of the numerator and denominator tie, there is a horizontal asymptote where you divide the leading coefficients. Okay, so I need to explain this one a little bit more, and I'm going to do that on Desmos. So let me pull Desmos back up, and let's look at this function, because it was the one that had a horizontal asymptote, but it wasn't approaching 0. So this one was approaching 2 as we went way out here in both directions. And I want you to look at this function over here that's next to the blue symbol. We have a tie. When we look at the degrees, they're both x squareds, top and bottom. So look in front of the x squareds. See the 8 and the 4? What's 8 divided by 4? Well, that's 2. Okay, now let me prove it to you that I would divide those two leading coefficients to see where the asymptote lands. So let me change these numbers. I'm going to make this a 12. So how about this? We have a 12 over 4. The degrees are still tied, So I'm going to look in front of them. 12 divided by 4 is 3. And if you look, 3 would be right here between the 2 and the 4. And do you see that asymptote? It is where the y value is getting close to 3. See how close to 3 it's getting? But it's not there. Okay. So let me do one more just to prove it to you. Let's say I had 12x squared divided by, I don't know, how about 4x squared? Wait, did I just do that one? Maybe I did. How about a 3? So now we still have a tie with the degrees. I look in front of those for the leading coefficients. 12 divided by 3 is 4. And do you see the horizontal asymptote happening where y equals 4? Okay, so that's what you do when you have a tie for the degrees. Okay, so now let's look at case 3. Let's see here. Case 3, if the degree of the numerator is 1 bigger than the degree of the denominator, it will be an oblique asymptote. Okay, so as far as Algebra 2, that's all the farther we're going to go with this. In pre-calculus, what you'll do is you'll find where that oblique asymptote is by doing polynomial division. Okay, so we've got the foundation laid for it because you've done polynomial division and you know that asymptotes exist and that they can be slanted. So you'll expand on that in pre-calculus. For now, it's enough just to know what kind of asymptotes you're going to have. So the degrees, comparing the degrees will tell you if you have a horizontal at 0, if you have a horizontal asymptote somewhere else, or if you have an oblique asymptote. If the numerator is bigger by 1 degree, then it's going to be an oblique asymptote. Okay, so it's going to look like it approaches a line out there. So, okay, that is everything. So remember that Jesus loves you and so do I, so do your math.